Very good morning to everyone. This is Selvaganapathy from Department of Master of Computer Applications. In this video, we're going to see about the architecting of distributed database, how it will be fragmented and how the query optimization will be executed and a distributed system. We'll see on this video. Yes, before that, we want to find what is the drawbacks of centralized database. In centralized database, we have a big problem is while the number of clients are increased, while the number of queries are accessing the database in the same time, what happened is that single point of failure will be occurred. So what it did know, we can't be able to retrieve the data on time. So it will be get that delay on the performance. We frequently see that the network was slow. So this is not a slow. This is called too many requests will be accessing that centralized data. What it happened? The many queries are accessing, many clients are access from different regions to access the same data, so it will be getting delayed to respond all these kind of queries. So if suppose we want to overcome this issue, so what we are doing, we are distribute our data to different regions, different sites. We are distribute our data to different regions. We are communicate through all other regions, all other nodes. We can access the data from different parts. So what? How we are overcome the centralized problem here? That if suppose one node getting delay or one node getting any problem, so we can get the data from some other data centers. So what it happened, it was give quick response to the client, so they can able to retrieve the data as much faster compared to centralized device. So the distributed database system is logically centralized, but it's physically distributed. It runs across multiple regions, multiple data centers. The data centers are located in the different countries. So, but even though we can able to retrieve the data without any delay, okay, it will be perform like a physical machine. So we don't feel that the data we are accessing from some other region. The client don't know which data center the data are retrieved from which data center. They don't know what. They feel that the process was executing very clearly. So the clear point, the distributed database system. The distributed database system is logically centralized but physically distributed. It runs across multiple integrated servers. It providing a higher availability, modular scalability, and parallel processing without sharing physical component. So we don't share our physical devices, physical databases. The data are stored in a different data centers. We can access that from different regional data centers. So we have two types of database ecosystems we are followed here. The first one, homogeneous ecosystem and heterogeneous ecosystem. Very simple. Very simple. Here, what this is my application, I am using different data centers in a different. I'm using different data center in different region. So what does it happen? Different data centers in a different region I am using here. All data centers are using same operating system as well same database. Clear? If suppose I am using I am sharing my applications, my database in different data centers. Each side have the same operating system as well, the same database like SQL, MySQL, Oracle, MongoDB, whatever it is. So they are using the same application. This is called homogeneous ecosystem. Okay, this common and uniform data structures will be followed in all different data centers. So this is called homogeneous ecosystem. If suppose we come to the next part, this is called heterogeneous ecosystem. Here, this is something totally different from homogeneous. Here are applications. We are saving our applications in a different data centers. They are following different operating system as well different databases. Clear? In a homogeneous, we are using the same operating system as well as same database in all data centers, all sites. Here in a heterogeneous, we are using a different operating system and different databases in every data centers. We are using different databases. So here Oracle, here SQL, here MongoDB, something MySQL. So like the same, we have a different operating system, different databases we are using. Suppose this is called heterogeneous ecosystem. This is something complex to define, and this is few corporations only, few industries only use it, suggest this heterogeneous. Most preferably, the homogeneous part will be utilized in Africa. Here we have next topic is called the data fragmentation, and it's a whole down. How we fragment our data in database in a table, how our data are fragmented. Here we have two type of fragmentation is there, horizontal fragmentation as well the vertical fragmentation. So horizontal fragmentation, it splits the group of rows, that's called tuples. The group of rows, it will be split that rows in we split the rows, that is called heterogeneous. Okay, like the same. And students in a computer science go to site A. If suppose student in some other department, it will be go for a site B, like this. For example, for example, if suppose we all purchase something in Amazon, we have a different data centers we are following. For example, if suppose we are in Tamil Nadu, we are focusing on that. The channels which was listed in Tamil channels will be we are frequently watching. If suppose we are in Karnataka, we are in UP or AP, the regional language will be different. So based on a region, our language will be transferred to something like the same. If suppose I can use that Amazon.in as well Amazon.com, we have the same products will be displayed over there. The Amazon.in, it shows that Indian customers will be frequently access that. If suppose Amazon.com, it will be the universal customers back, and they can able to, we can use what we call, yes, it's something called horizontal fragmentation, that the data are splitted by the row wise. If suppose it's called vertical fragmentation, the data are divided in column wise. It will be in it is called in a row wise, as well it is in column wise. So the next what we see now, that is called replication. So this is that main future in a distributed database, because the data is not only stored in a single node. The data are stored in different nodes. If suppose we are saving the data to the single database, the data are the same data will stored in different region databases. If suppose is happening like that, then we can no bother about our data loss. If suppose any of our region data was collapsed, we can retain the data from some other data centers. So that's the main beauty of the replication what we are using here. And yes, okay. The main benefit of this replication balancing. So the highly data available, and then its reliability. Is the data are highly available, and it's very reliable data we can store in each node. Okay, and the copies will be ensured, and it will be query response will be very good, and system we can retrieve the data during the site failure. This is the main benefit of replication in a distributed database. So what is that? What are those things we want to focus here? It will be that synchronization will be overheaded, because every single update want to happen in all these different nodes. I don't update the data in a single data center. I want to update the data on every data center. Every data center I want to update my data. That is the cost of this replication. What is it? The data want to update every data centers. We want to store the data, update the data. Both the things want to happen in a simultaneously, then only we can retrieve the data. If suppose one data center was collapsed, how we manage that? That is called the synchronization of replication. We have using here that commit protocols we are using here. That is, the first one is called two-phase commit protocol. What is that two-phase commit protocol? What is did you know is something very interesting. If suppose I send a data to the two different nodes, if suppose I get an acknowledgement from these two data center, then only it will be commit. So what is commit? It will be something like we save the data. Okay, we save the data. That is called commit. Okay, so two-phase commit. This is nothing but once we send the data to the data center, the data center want to acknowledge the data are received. If suppose If suppose one data center give acknowledgement, I receive the data. Another data center don't send acknowledgement to the client. What happened? This not be committed. The data not be saved, because that's called two-phase commit protocol. If suppose the two-phase commit protocol is nothing there, the coordinator the coordinator and participant. Coordinator and participant. Coordinator pass the data to the participant. The coordinator pass the data to the participant. If the participant don't acknowledge, any one of the participant don't acknowledge the process, it's not being committed. That means, see, this data center give acknowledgement, this data center don't give acknowledgement. That means the data not updated in both data center. It will be rolled back. This is not updated. That is the beauty of replication. You know that when we are updating a data, which want to update all the nodes. What are the data centers we are using? All data centers should want to update the data. Okay, clear. If suppose any one data center not accepted, not acknowledged, one data center not acknowledged, the remaining data centers are give acknowledgement, even though this update will be terminated. Is not be updated in all other data centers. Clear? That is called two-phase commit protocol. It ensures that the replication update simultaneously perfect consistency but slow writing speed. Because we want to wait for the acknowledgement from all the data centers. So it's getting some time to complete it. So that's that replication two-phase commit protocol. How we are asynchronized it, how we are overcome it. So we are doing that another process that is called three-phase commit protocol. Something this is similar here. If suppose what happened here, the client send a request to different data center, all data centers or give acknowledgement to the client. If suppose all data center give acknowledgement, then only we can update the data. But here the data will be stored in a local system. Later the data will be updated to the data centers. Okay, the primary site update first, the secondary the site update later. It will be faster writing, but temporary data inconsistency exists. That means the data were updated in the local system. After after that, it will be updated to every data centers. Okay. So here the only problem we are having that temporary data inconsistency exists, because what data updated in the local system that not be updated in the data center. So we want to overcome it. So here it will be possible, but it getting this is called fast writing. The data was written very fast in a local system, but we want to circulate, we want to store, update it in our data centers. It's getting some delay. Okay, distributed transparency, the data is how it will be transferred. We can be able to easily know that how the data will be stored, how we can retrieve it. The location transparency, the user queries tables without knowing the physical network address or remote address. If suppose we are searching some product in Amazon or Flipkart, something else, we don't know where the data are stored, which database, which data centers they are using. We don't know about it, but we can able to retrieve the data from the Amazon or Flipkart, something else. And fragmentation transparency, we don't know bother about it, because we are Indian user. The site will be fragmented based on horizontal or vertical, which data the customer want to know about it. Like that, it will be automatically happen. But the fragmentation, the user code is a table. If we don't retrieve the whole databases, what the data we need, it will be fragmented. The data, the region data will be accessed frequently. And the important thing, replication transparency. The user updates the record once, the system silently update all hidden copies across the network. This follows the very beauty of distributed transparency. And the journey of data queries, the user send the query decomposition, the what is that the SQL query scanned and processed and translated into global relational algebra tree. The data will be the data location will be identified using that query and using the fragmentation and where the data are available. And global optimization, it will be equates the network constraints and choose the best execution path, and for minimum data transference and distributed execution, it will be local sites can run optimized subqueries, transfer the data, and the final the output will be received to the user. And we here we are like just now we are seeing about the concurrency control. What are the concurrency controls available in a distributed database system? Two-phase lacking, the mechanism phase one, it will be growing and it will acquire all logs, and the phase two is sharing release them. We are two type of locking process we are using here in our distributed database system. The distributed this it will be required a centralized or a primary copy lock manager, and it guarantees that serializability, but it strictly limits system parallelism. And timestamp ordering, the mechanism which was transactions or processed over is first based on unique site ID on the clock reading, and that is if you are how we are overcome on this no lock required now. The younger transactions are immediately about or faster waiting, they clash with older friends. And optimizing consistency mechanisms, here no conflict, execute locally, then globally it will be validated. And here perfect for a system with a low conflict rate, avoid a massive network overhead distributed lag management and calling. And the deadlock situations, the strategy how we are overcome it. Here the deadlock, we know that the transaction was the waiting for another transaction. We need an input from transaction 2. Once we receive the input from transaction 2, then only transaction A will be completed. But the problem, the transaction 2 waiting for the input from transaction A. It will be a deadlock situation. It will be we can't able to move further. This is called the deadlock situations. So how can we avoid this deadlock situation? This is called wait die algorithm. It will be what is that? If suppose transaction 1 is older than transaction 2, transaction 1 will wait or abort. Okay. If suppose transaction 1 is younger, it will be die, the abort transaction will be restarted. The wait algorithm, what is the date? If transaction 1 is older than transaction 2, what happened? Transaction 1 would abort transaction 2. Transaction 1 will be wait continuously. If suppose we are following these things, the deadlock situation will be avoided. And and so commit protocols, what we are discussed in earlier slides. No preparation phase, the coordinator send a request to different site. We want to get a acknowledgement from all these sites, then it will be updated. The commit will be confirmed. If suppose we don't receive acknowledgement from a particular site, all three data centers not be updated. This is called two-phase commit protocol. Okay, and we have a failure and the recover timelines. We have three types of failures be here. Soft failure, it will be that memory crash or power failure. This is called soft failure in a distributed systems. And hard failure, the disk physical crashes. And achieving backups and roll forward mechanism. This is called hard failure as well as network failure that link participation address via step two phase commit protocol. These kind of failures will be possible in distributed database system. Okay. Okay. Thank you. The remaining things we will discuss on our next slide. And thank you for listening.